Hi, welcome to Dark Dragon Does Math, and we're doing transversals today. More importantly, we are doing parallel transversals. So I'm going to say that this will be easier if you have multicolored writing utensils around. If you have like maybe crayons or colored pencils or markers or something, it might help. If you don't, and you're in my classroom, I have a supply. Otherwise, you'll be all right. But I'm going to be very colorful today. So we're doing transversals, and normally here I would write a definition down. I'm not going to do that today. Instead, I'm going to show you. So if it says blah 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 is a transversal, this right here that I'm drawing is a mediocre transversal. Now, most transversals that we worry about are parallel. So if you ever see little arrows like the ones I just put on the page, those symbolize parallel lines. So what we've got here are two parallel lines and a third line that cuts between them, kind of connects them. This third line, that's the transversal line. So this is a transversal here, specifically this line right here, the one by itself. So two parallel lines and a line that meets them. Now I want to talk about alternate interior. Now we know that the interior of a building is the inside. So just like that, the interior of a transversal is going to be inside the two parallel lines. Also, this says alternate interior. So notice that this green is on this side and this green is on that side. Those are alternate interior. They're alternate interior angles. They are on the opposite sides. I'll show you another pair. These right here. They are on opposite sides of the transversal line. Hence the word alternate. And they are on the interior of the transversal. Think about this is inside the house. They're inside there. So those two are examples of alternate interior angles. And the reason that they are important is because they are congruent. And if we remember what congruent means, it means equal. They equal each other. They're the same. So if this was 85, the other orange would also equal 85. And what I'm going to also kind of bring in, same color means they equal the same thing. Okay, so keep that in mind. Now I want to show you alternate exterior angles. What is an alternate exterior angle? Let's get a different color. So here's one exterior angle. The alternate exterior would be all the way over here. So this little green guy over here and this little green guy over here are alternate exterior. Basically, again, think about instead of the inside, we're thinking about the outside of the that's hard to do. The outside of this transversal here, that's the exterior, and they're on opposite sides of the transversal line. Again, why this is important is because they're congruent. So alternate exterior are on opposite sides of the outside of the transversal, are the parallel lines. Opposite sides of the transversal, outside of the parallel lines, exterior of the parallel lines. These two are also alternate exterior. Corresponding angles. Get a different color. So a corresponding angle, and I'm going to be kind of that right there and that right there are corresponding. Basically, the angles that, how do I put this? I'm just going to color in over that because I can't. The corresponding angles are on the same side of the transversal line and are on the same side of the parallel lines if you look at it like that. So corresponding, they're both on the left side of the parallel lines. Another set of corresponding angles would be this guy right here and this guy right here. Those are corresponding. Another example would be this guy right here and this guy right here. Oh, you can't see that. This guy right here and this guy right here. So corresponding angles are also important because they are, some of you probably said it already, congruent. Yeah, they're all congruent. So let's do this again in a second. I'll come back to that. So we have alternate interior angles, which are on opposite sides of the inside of the transversal. We have alternate exterior, which are on opposite sides of the outside of the transversal. And we have corresponding, which are on the same side of the same side of the transversal. It's a lot of information, but over time, you'll be able to notice them a lot easier. So let's talk about this. EF, CD, and GH are straight lines. EF is parallel to CD. Well, we know all of that. So let me show you some. Identify two pairs of alternate interior angles. So two pairs of alternate, I should really say a pair of alternate interior angles. Oh well. So a pair of alternate interior angles would be this guy and this guy, alternate interior. Okay, so the way we write those down is we can say that angle EAB is alternate, well, I don't want to write all that. EAB and DBA. So that's how mathematicians would want you to write it. That's how they're going to want you to write on the ACT. But because we use colors, orange and orange, yeah. Sorry about that. Identify a pair of exterior, alternate exterior angles. Let's do green again. If I pick this one right here, the exterior one is going to be right there. They are on opposite sides of the outside. So technically, that's angles GAF, and angles CBH. But because colors are fun, they're green. And finally, if we want to identify a pair of corresponding angles, man, I'm typos all over the place. How about this one right here? So if I pick this one, there is only one angle that corresponds with that angle. It is this one right here. It is on the same side of the transversal line, and they're on the same side of the two parallel lines. So those two are corresponding. So technically, they are EAG and CBA, but it's more fun, and honestly I think it's more, I can see it better. We just say they're blue ones. They're blue ones. So I'll show you this down here before I do anything else. So remember that alternate interior, alternate exterior, corresponding angles are always equal to each other. So let's do a little angle chase here. So I'm going to call 6, which is 123 degrees orange. So first off, I want to label all the angles that I know are the same as orange. The first one I'm going to do is 8. 8 is the same as 6. Now the reason is because they're vertical angles. They're on opposite sides of straight lines. We talked about that last 6.2. They're vertical. I also know that 6 is the same as 1 because 6 and 1 are alternate interior angles. I also know that 6 is the same as 3 because 3 and 6 are corresponding angles. And we can go further. Look, 3 and 8 are alternate exterior, so they're obviously going to be equal to each other. 3 and 1 are equal to each other because they're vertical. 1 and 8 are the same because they're corresponding, and we can play that game all over and over, all around. So all the orange ones are the same. We can play that game some more because I'm going to call 5 blue, and if 5 is blue, 7 is blue, and if 7 is blue because it's corresponding to 2, 2 is blue, and since I have 5 right here, 5 is also corresponding with 4, or 7 is alternate exterior to 4, and 5 is alternate interior to 2. But we have a bunch of angles that are equal to each other, which is great because it helps us a lot in terms of deciding, well, if I know this is 123, what are the rest of them? Because if that's 123, every orange is 123. So what's the measure of angle 3? Angle 3 equals 123 degrees. What's the measure of angle 1? Oh, it's also orange. Angle 1 is equal to 123 degrees. What's the measure of angle 2? Angle 2 is blue, so it's not 123 degrees, but it is supplementary to it since that's a line there. So angle 2 is equal to 180 minus 123, which means that angle 2 is equal to 180 minus 123 is 57. 57 degrees. Cool. Now, it may feel like I didn't explain a whole lot, which I haven't gotten super into it, but knowing this is enough. So that's actually the end of my part of your notes. So on the back here, oh, not the back here. The back here, I want you to tackle these questions. So when it says why, you need to tell me, is it because of corresponding? Which two angles are corresponding? If you want to color them, I don't care. But notice we have two parallel lines right here. Those are the two parallel lines. So that means that we have two sets of transversals. We have one transversal here, and we have another transversal over here, where the angles will not be the same for each one of them. So just keep that in mind. And you can play around with, like I said, colors. We know this one right here. That's the same as this one right here, and which is the same as this one right here, and so forth. But try to think of a reason why. Color it in, do that. Pay attention to EH. The book's real good about being very specific with that. That's why I like colors. So, and then do number 2, and we're good. So, have a nice day. I hope that was helpful. Really do. If not, always here. Ask me questions in person though. Slow down, watch it again if you need to. Have a good day. Math!